Okay, good morning again, everyone. Today we move on to Chapter 3. Today we'll look at solving a system of equations. This may be familiar to you. We'll look at solving a system of equations using substitution, and then the second video will be solving a system of equations using elimination. But first, let's figure out what it means to solve a system of equations. So our objective today is solve a system of equations using substitution and elimination. So things you may have done before, we have a algebraic expression 2x plus 6 is equal to 4. So how do you solve that? Well, you would subtract 6 from both sides. So this should be quite familiar to you. And so we would get 2x is equal to negative 2. And then finally we would divide by 2 and we would get x is equal to negative 1. Okay. So when x is equal to negative 1, 2x plus 6 will equal 4. Now, you never looked at it like this, but actually when you were solving for x, you were solving a system of two equations. And those two equations were these here. And we draw this little curly bracket to represent a system of equations. So the first equation was y is equal to 4. Okay, so that's that value there. Y is equal to 4. The other equation is y is equal to 2x plus 6. And so that's that expression here. That's that expression, 2x plus 6. So we have two equations. We have a system of equations. If I were to graph those out, y is equal to 4 is just a horizontal line. Y is equal to 4. And then y is equal to 2x plus 6. My y-intercept is 6. I start at my y-intercept, which is 6. And my slope tells me to go up 2 and over 1 and up 2 and over 1. Or I can go down 2 and over 1 and then down 2 and over 1 and down 2 and over 1. And then I can draw my line here. So that's the equation y is equal to 2x plus 6. So I have a system of two equations. One is y is equal to 4. That's that line. The other one is y is equal to 2x plus 6. Oops, I want a different color. Y is equal to 2x plus 6. And that's that. And that little curly bracket, that system of equations, actually says this. It says find the value of x that makes the y's equal, or where they intersect. And that would be right there, where x is equal to negative 1. So that coordinate point would be negative 1 and 4. Y is 4 there. Okay, so when we are actually solving 2x plus 6 equals 4, we're actually solving a system of two equations. One is y is equal to 4. The other one, y is equal to 2x plus 6. We're asking, what is the value of x that makes the y's equal? All right. Now, so solving a system of equations using substitution. The graph shows a system of linear equations. As you can see, without the use of technology, determining the solution from the graph is not easy. Why do they say it's not easy? Well, notice here that the intersection here, it doesn't cross the grid lines. Okay, it looks to be about, x is about 0.8, and then y looks to be about 1.3. Now, we can use substitution, however, to find an exact solution rather than guessing. In substitution, you solve one equation for one variable, and then substitute this expression into the other equation. So these are the steps I say you do. Number 1, you find an expression. You solve for x or y. For x or y, you find an expression for x or for y. You substitute the expression for x or y from step 1 into other equation. Then you solve for the value of x or y from step 2. And then finally, you take that value you got from step 3 and you substitute the value of x or y into equation in step 1. And those are the steps you do. So let's take a look at this. So here I have a system of equations, a little curly bracket. One equation is y is equal to x minus 1. The other equation is, x plus y is equal to 7. So step 1 says find an expression for x or y. Well, notice I already have an expression for y, and that expression is x minus 1. Y is solved for. So now step 2 says substitute the expression for x or y from step 1 into the other equation. So I'm going to take this expression for y, which is x minus 1, and I'll replace that y with that there. I'll replace that y with x minus 1, which is what they did. X plus x minus 1 equals 7. And then step 3 says solve the value of x or y from step 2. So that's what we do. So we combine our like terms. X plus x is 2x. So 2x minus 1 is equal to 7. 2x is equal to 8. X is equal to 4. We found the value of x. We found the value of x. Now what do you do? So we got the value of x. Now you take this value of x, which is 4, and you substitute it back into the equation in step 1. So this has to go back up in there. And so this is going to be y equals 4 minus 1. Y is equal to 3. So my solution here, as a coordinate point was x is 4 and y is 3. And that's the value of x that makes those two y's equal. And we can check. So when I have y, first equation, y is equal to 4 minus 1. Okay, but y is 3, so here we said 3. And 3 equals 3, it checks out. And then equation 2, so we have x is 4, so 4, and y is 3. And we say it equals 7, and 7 equals 7, it checks out. Okay? It checks out there. So again, what are the steps? You find an expression for x or y. You substitute the expression for x or y from step 1 into the other equation. You solve for the value of x or y from step 2. And then you substitute the value of x or y into equation in step 1. You do that each and every time. So let's look at this one here. Here I have two equations. Okay, I'm solving a system of equations. But neither equation is solved for either x or y. I'm going to ignore this here. Because here, we're just going to, equation number 1, we'll just solve for x. So we have equation 1 and equation 2. So that means I need to isolate x. So what do? I subtract 2y. So we have x equals 4 minus 2y. Okay, x is equal to 4 minus 2y. So now we're going to take that expression, 4 minus 2y, and we're going to substitute it in. So that's x, and now we're going to substitute it for that x into that other equation. Okay, so we have 3 minus 4 minus 2y. That was the expression for x. Minus 4y. We distribute. 3 times 4 is 12. 3 times negative 2y is negative 6y. So we have 12 minus 6y minus 4y equals 7. Okay, we combine our like terms. Negative 6y minus 4y gives us negative 10y. So we have 12 minus 10y equals 7. Finally, we subtract 12. We get negative 10y equals negative 5. And then you divide by 10. And you get 5 over 10, or 1/2. So there. So we found the value of y. That's step 3. Okay. Step 1, we had to solve for either x or y. We solved for x. We did that. We said x is equal to 4 minus 2y. We take the expression for x. We substitute it into the other expression. We did that. 3 times x is now 3 times 4 minus 2y minus 4y equals 7. And then we solve for y. That's step 3. The last step then is to substitute that back into the first equation. Okay, and we have to substitute that back in there. Okay, and when we do that, final step, we get x equals 4 minus 2 times 1/2. And so that's 4 minus 1/2 of 2 is 1. And so we get 3. So x is equal to 3. So my solution is 3 and 1/2. X is 3 and y is 1/2. Let's look at one more example here. Okay, so here, again, we have two equations. We have a system of equations. We have to solve for either x or y. Notice here that y is almost solved for. Okay, it's a negative y. We don't want a negative y. We want a positive y. So what can I do? Well, I can multiply the entire equation by a negative 1. Negative 1 times 2x gives me negative 2x. Negative 2 times a negative 1 gives me a positive 2. And a negative y times a negative 1 gives me a positive y. Okay? So when I multiply the entire equation 2 by negative 1, I get y is equal to negative 2x plus 2. So we found the expression for y. Now we take that expression, which is 2x minus 2, which for y, and then we substitute it into the top equation. Okay, so we're going to replace y with negative 2x plus 2. So that's what they did. So we have 5x plus 6, but y is negative 2x plus 2, and that equals 9. Okay, so now step 3. We have to solve for x here. Step 1, we solve for x or y. We did that. We said y was equal to negative 2x plus 2. We took that expression, negative 2x plus 2 for y, and we substituted it into the other equation, 5x plus 6y. We replaced y with negative 2x plus 2, and that's what we did. Now we have to solve for x. Okay, so here, this continues down here. Oops, so we have to distribute that 6. So we have to distribute the 6. 5x, 6 times a negative 2x is a negative 12x, and 6 times 2 is 12, and then that equals negative 9. We combine our like terms. 5x minus 12x gives you negative 7x, and then you subtract 12, and you get negative 21. They did a lot of steps there, right? They skipped a lot of steps. So here we had negative 7x plus 12 equals negative 9, and then they subtracted 12, and then I got negative 7x equals negative 21. Right, I skipped a couple steps there. And then finally you divide by negative 7, and you get x is equal to 3. That's the third step. Now we take that value for x is equal to 3, and we substitute it back into what we found for y, into that expression there. So x is 3. So now we'll know that y equals negative 2, x is 3, so negative 2. So 3 plus 2, so y is equal to negative 6 plus 2, so y equals negative 4. So my solution is 3 and negative 4. Let's just check to see if that works here. 3 and negative 4. So I'm going to start with this equation here. Let's see here what we get. We said x was 3, so 5 times 3 plus 6 times negative 4. We say that equals negative 9. Let's check out. 15 minus 24 equals negative 9. That's true. Negative 9 equals negative 9. That checks out. And then the other one. So we have 2. So that was that. So we have 2, and we said x was 3 minus 2 equals negative, and we said y was negative 4. So this is 6 minus 2, that's 4, and the opposite of a negative 4 is 4, and that checks out. Okay, so it checked out. Okay, so that's substitution. That's substitution. Again, what you do this each and every time. These steps here. You find the expression, you solve for x or y. You substitute the expression for x or y from step 1 into the other equation. You solve for the value of x or y from step 2, and then you substitute value of x or y into equation in step 1. And then you should always check your work.